Section 15A, question number 6, page 364. The question asks us to find the gradient function of f of x when f of x is the following. Question A, part A is 4 root x plus x. I'm going to rearrange that, or rewrite that as 4x to the 1/2 plus x. And now I'll find the gradient function of this by differentiating. So that's 4 times 1/2 x to the negative 1/2, because I'm taking a half and I'm subtracting 1 from that exponent. And then the derivative of x is just 1. And now I'll simplify this a little bit, so I get 2x to the negative 1/2 plus 1. And I'll change this back to the original form of the square root form of this. So I get 2 over root x plus 1. Part B, f of x is the cube root of x, and I'll rewrite that as x to the 1/3. And now I'll take the derivative and bring the exponent down in front, and then I will subtract 1 from the exponent to give me negative 2/3, and then I'll rewrite that into the same form that it was given in the original question. So I'll have 1 over 3 the cube root of x squared. Part C, f of x is negative 2 over root x. Rewriting that, negative 2x to the negative 1/2. And now I'll take the derivative, finding the gradient function. So when I multiply negative 2 times negative 1/2, because I bring that down in front, subtract 1 from the exponent to give the exponent of negative 3/2, simplify this to get 1, and then I'll return it back to its original form. So that just gives me 1, so it'll be 1 over the square root of x cubed. Now, x cubed can be written as x squared times x. So I get x squared times x, the square root of that, and that can be rewritten as the square root of x squared times root x, and the square root of x squared is just x, so that leaves me with 1 over x root x. Part D, f of x is 2x minus root x, rewriting 2x minus x to the 1/2, and then I will differentiate. The derivative of 2x is just 2, and then bring the 1/2 down in front of this and subtract 1 from the exponent to leave me with negative 1/2. So that gives me 2 minus 1 over, now this 2 is already in the denominator, and then that x to the negative 1/2 brings the x down into the denominator, and we take the square root of that to leave me with 1 over 2 root x. Now I'll move along to part E. F of x is 4 over root x minus 5, which gives me 4 multiplied by x to the negative 1/2, kind of the opposite of what we just did up here in part D. Bring this up to the negative 1/2, and then I still have this minus 5 here, and then I will find the gradient function by differentiating. So 4 times negative 1/2 gives me negative 2x to the negative 3/2, because I subtract 1 from that exponent, and the derivative of negative 5 is just 0, because the gradient of a constant or a horizontal line is going to be 0. And then this drops down into the denominator, so I get negative 2 over the square root of x cubed. In the same way we simplified part C, we're going to simplify part E here. So I've already seen that the square root of x cubed ends up giving me x root x. So I got an x cubed here, so I'll just rewrite that as x root x as well. Part F, write this up a little bit higher. I don't know if I'll be able to save some space or not. F of x is 3x squared minus x root x. Now here, notice that we're getting this the same as we rewrote as in this function here, so we could probably undo that simplification so that we can differentiate it a little nicer. So that becomes minus x to the 3/2, because that would be the square root of x squared, and then when you multiply the square root of x squared times the root of x, we would get the square root of x cubed, which can be rewritten as x to the 3/2. And now we take the derivative of this, and the derivative of 3x squared is 6x, and the derivative of x to the 3/2 is 3 over 2 x to the 1/2 after subtracting 1 from the exponent. And now we'll rewrite it into square root form. So we get 6x minus 3 over 2 root x. I will write g down here. Hopefully we have some space. F of x is 5 over x squared root x, which is 5 over the square root of x to the power 4 times root x, which then is 5 over the square root of x to the power 5, which is 5 times x to the negative 5/2. So now we can take the derivative of this, find the gradient function, which is when I bring this negative 5 over 2 down and multiply by the 5 as the coefficient, we get negative 25 over 2, over 2 x, and subtract 1 from this to get negative 7 over 2. And then rewriting, negative 25 over 2 times 1 over the square root of x to the power 7. And then I'll do the same thing, trying to simplify a little bit here. So you get negative 25 over 2 times 1 over, and I'll have x squared times x squared times x squared times x. Let's break it apart 3 times. All under the square root. So the square root of x squared and the square root of x squared and the square root of x squared all just become x's. So we're left with negative, and now I'll put the 25 in the top by multiplying by 1, and I have a 2 here, so x cubed root x.